Our next session is just going to be amazing, and it's from Skylab to the ISS. So we brought together current and former high school student scientists to talk about doing research in space. One set of panelists conducted experiments as high school students 45 years ago on Skylab, America's first operational space station. The other set are current high school students who are doing research on ISS right now. So this is all of them. This is very cool. And excellent, thank you. And I'd like to invite up Dan Barstow, Senior Education Manager for the ISS National Lab, the driving force behind Space Station Explorers program, and co-host of this session, to introduce our very special moderator. Dan?
Thanks, Jim. Yay! Well, what a pleasure to be here today. Today, with the conference, is STEM Day. Every year on Thursday, we do this, first of all, to honor all the students and educators who are doing STEM projects, but also to invite some guests here. So I'm pleased to say that in our audience, we also have some students from the Augusta Boys and Girls Clubs, from Zero Robotics and Genes in Space, and a few other programs. So a big welcome to those students as well. And of course, a big welcome to our panel that you'll get a chance to hear. They'll each have a couple of minutes to say a little bit about their story, and General Bolden will interview them. But I'd like to clarify that today's agenda, actually, this session has two parts. The first part is now about these students and talking with them. That lasts about an hour. The second part are a series of awards to Student of the Year, Educator of the Year, and the Genes in Space competition. After that, then you have the break for lunch. So just so you know the sequence there. So with that, let me introduce our esteemed host, Charlie Bolden. Many of you know him. He was NASA Administrator for 8 years, from 1909 to 2017, appointed by President Obama. During his tenure, General Bolden managed the safe transition from 30 years of space shuttle missions to a new era focused on full use of the International Space Station and other cutting-edge space exploration programs. He initiated the shift to the commercial space transportation system that's doing now ISS resupply and the much-anticipated return of American astronauts launching on American rockets on American soil. He was the commander of 2 space shuttle missions and pilot of 2 others. So thank you very much, Charlie, for joining us.
Thank you. Thanks very much. Okay, I have a very simple mission here, and it's be brief, be something, and be gone. So let me say what a pleasure it is for me to join the august group of people on the stage. I'm really interested in hearing your stories because I've tried to talk to as many of you as I could. I was unsuccessful in getting to everybody. If I screw somebody's name up, please forgive me as we go through this. But this is a very special occasion. Every year now we've been getting together to talk about the International Space Station, the work that's going on there. And then this STEM Day is really special because it gives us an opportunity to step back and to focus on the students and student involvement, because most of us believe that's a critical part of everything that we do. NASA's vision talks about reaching for new heights to reveal the unknown so that what we know and what we learn makes life better back here on the planet. So that's really the hope of everything that's going on the station. When Serena talked to you yesterday, for those of you who were here for her talk, I think she emphasized the fact that everything that she did on station, she had in mind making life better for people back here. So that's one of the reasons we have this big STEM Day. The other thing is we want to really encourage diversity and, most importantly, inclusion. And I have to differentiate between the 2 words for you. Diversity is what we have in the audience to some extent. It's men, women, people of different races, different creeds, different nations, and the like. That's good, but it's not any good if we don't develop inclusion, which means giving everyone an opportunity to speak. So today, if you look up on the stage, you're going to have an opportunity for young people, and young, at my age, everybody's young. So you're going to get an opportunity for young people to talk about the experiments they did both on Skylab and now on the International Space Station. So without further ado, let me give it back to Dan, and then we'll get on with the presentations from the students and a little bit of time to talk to them.
Thanks, Charlie. Just to clarify, we represent the International Space Station U.S. National Lab and its educational program called Space Station Explorers. Space Station Explorers is really a consortium of some 40 different organizations, all working creatively to engage kids in doing space missions. Now, what we have is a profoundly important idea. Space education used to be an expert explaining things to you and you were impressed, and maybe 30 years from now you could do that. Now we have a whole different model of a direct involvement. We have Zero Robotics, where students program code to control a robot on space station. We have Exolab, where students monitor and experiment now in space on the SpaceX 18 that has bacteria growing that they're monitoring. We have ham radio operations. And by the way, Frank Bauer, who founded the ARIS program, submitted a proposal to the Skylab program, wasn't accepted, but continued his interest. We also have the Quest program with students programming experiments on the ground to go up to space. We have Genes in Space, Tomatosphere, planting seeds. All of these are engaging kids in doing science. Competitions and presentations. What we have is a revolution in space education. You have to understand how deeply important this is, how it transforms the model of students impressed with others to actually breaking through the boundaries and having their own classroom in space. Students learn by doing. They learn STEM, science, technology, engineering, math. They learn the softer skills of teamwork and problem solving and confidence and career awareness. At least we think so. It's hard to tell for sure because many of these things you do not see the impact immediately. You don't see it until years have gone by. How could we possibly find out that impact over time? So, we did a little bit of history, and it turns out that the Classroom in Space program, launched by NSTA and NASA in 1972, solicited experiments from high school students around the country. They hoped they might get a half a dozen, maybe fly one. They had thousands of entries. They narrowed it down to regional winners and then selected 25 students to do their own experiments in space. Well, now 45 years have gone by. What impact did that have on them? And how does it inform how we can do our educational programs? So, we have 3 of them here who were in this picture. We tracked down about 18 total, and you'll hear from a young woman who did the actual interviewing and tracking down. But just to be clear, the Skylab was the first space station flown in 1973-74, a little bit problematic at the start, broken solar panel, a few other things that they had to deal with, but they were able to successfully have this operate numerous experiments, some 56 science experiments and others that they operated there using telescopes and spiders and so on. 25 of those were student experiments. Well, you don't want to hear from me about that. Why don't we turn now to an astronaut who actually participated in that Skylab mission? I should say the agenda does say Ed Gibson. Ed did create a video, but we were able to connect up with the commander of Skylab 4, Jerry Carr, and I'll turn it over now to General Bolden.
Jerry, how you doing? I see you sitting there in your luxury of your office up in Vermont, so hopefully it's a good morning for you.
Yeah, good morning, Charlie.
Well, for the audience, Jerry was the commander of Skylab 4, and Skylab 4 was the 3rd crewed mission in the Skylab program. It was an 84-day mission, the longest that we flew in Skylab, and as Dan mentioned, it flew the latter part of 1973, went from November 73 into February of 1974. Jerry's crew members were Bill Pogue, who was his pilot, and then the science pilot was Ed Gibson. It's my great pleasure now to introduce to you formally my good friend Jerry Carr. He's a Skylab astronaut, he's an aeronautical engineer, and he was a pilot like me in the United States Marine Corps. He was selected to be a NASA astronaut in 1966. He served as the capsule communicator, or commonly called CAPCOM, for Apollo missions 8 and 12, and most importantly, as we've already mentioned, he commanded Skylab 4.
Could you ask him to mute his computer?
Oh, They tell me to ask you to mute your computer there, Jerry. So I'm not sure how you do it, but we'll see what happens. I think it's actually me with the ricochet coming back from somewhere. How's that? Is that better?
Yeah.
That's better. All right, we're good.
Well, that I can't hear what you're saying unless I use my phone, so I'm sticking this thing in my ear.
Okay, then I tell you what, once I finish with this long introduction, you can unmute your computer and put your phone down. How's that?
Okay.
Yeah, because I want you to be comfortable.
A bit more volume on the phone.
All right, then Jerry logged nearly 3 months in space. He managed a range of science experiments, including many of those pioneering student experiments. And that's what I want to talk a little bit about with you today. So you can unmute your computer and put your phone down so you can hear better, Jerry, if you want to do that. So now, first thing I want to ask you is, can you talk a little bit about your memories of doing student experiments, and particularly if you remember the one we were talking about yesterday that kind of challenged you, if you can talk a little bit about that one, because we happen to have the experimenter here on the stage with us.
Okay, we were really very interested and intrigued by the idea of doing student experiments on Skylab 4, so we were all eagerly looking forward to which ones we were going to get. The crew ahead of us, we got the spider experiment. They got the chance to see how the spiders manage to spin webs. And Annabella and Arabella, I believe, were the two spiders. They each spun the web, and they were pretty lopsided. It was clear that the spiders depended on gravity for such The other experiment that I remember particularly was what we call our monkey board. Now, it was an experiment where we had a board in front of us that was about 6 inches square, and it had a pattern of dots on the board, and the dots were all connected by, hang on just a minute.
The one thing we didn't think about was incoming phone calls. And while Jerry stepped away, just for some of you, Kathy, raise your hand. Kathy Jackson here on the end is actually the student about whom he's speaking, and she's going to talk a little bit about it in a few minutes. Go ahead, Jerry.
Well, anyway, this connection of these dots were all connected by in a pattern with a black line, and so what we were to do is take the stylus and stick the end of the stylus in the hole, as the first hole, number one hole, and behind that was a metal plate up there, in which you made it compact. And so we would stick it in the hole and pull it out, and then follow the line to the next hole, and follow the pattern, following the lines all the way down the way. And hang on. That's going to be wonderful. Anyway, then we were supposed to do it faster and faster. And the goal was to see how fast you could do it and hit every single one of the proper holes at the proper time. And so it was quite a challenge for us. It was really a lot of fun. And we all look forward to that one.
Fantastic.
Another one that we had that was really interesting, I think it was the rice sprout. I think there was a rice sprout in a medium, and in this medium, the sprout was growing, and we shined light on it, and so the interesting thing was to find out whether it grew toward the light or whether it grew according to gravity. And I don't remember just exactly what the results of that one was, but it was an interesting little experiment. We watched that little rice sprout grow. One of the others we had was goldfish and goldfish eggs. And these little goldfish, they were in a little plastic and the adult goldfish just could not figure out what to do. Meanwhile, the little eggs began to hatch, and we could get buried with a magnifying glass. We could see these little polywalls like little fish moving around, and they had no trouble at all. They were accustomed to their new environment, and so they swam in straight line, and looked at their parents and said, probably, what's going on? But that was an experiment that we had a lot of fun with it too. So all in all, high school experiments were a great deal of fun.
Great. Jerry, given where we are today with the International Space Station, do you have any thoughts on the contrast, if you will, between experiments on station and what you all were able to do on Skylab?
Well, I think the experiments on the station are much, much more sophisticated than what we had. Ours were really simple experiments that had important results, but necessarily because of the lack of technology we have here, our experiments have to be simple but effective, and that's the difference. The Skylab experiments were simple but effective on the International Space Station. There is much more of a scientific freedom available because of the technology available on the International Space Station.
And then I guess my last question to you before we let you go for the morning, just talk to me a little bit about what you feel the power of students doing experiments in space. As an astronaut, you're expected to do that kind of stuff, but talk to me a little bit about what you feel is the power of actually having a student experiment conducted in a place that most people think, would normally be impossible, a student experiment in space.
I think having a student element in space is incredibly valuable because it's going to inspire some students to become scientists and engineers and technology experts. And that's what the church needs. We need people who are interested in science. Back when I was a kid, if you were a scientist, you were considered the kind of a nerd. That word existed by anybody who liked to do math or who liked to do science was kind of strange because most of the other people do other things. Over the years with these STEM programs, and we have managed to bring the level of science up in terms of desirability to young people. We have managed to bring science and technology up to a very high level. I think that's great.
Great.
Right now, I'm very much involved in doing that little art with my wife, and so we are very interested in what we call the STEAM project, that's science, technology, art, and engineering, and that. Art's a very important part of your developmental development as well as the engineering. So with a good engineering program, the engineers, the scientists really ought to be looking out the corner of their eye, saying, I really need to learn a little bit more about art because that's more about our culture and where we came from, and it's very valuable.
Jerry, let me thank you so very much. And I'm glad you mentioned the arts at the end because a very good friend of yours and mine, the late Alan Bean, after he left the space program, became a world-renowned artist, and it fulfilled a dream that he had even before he flew. He liked to tell people that he was an artist who became an astronaut. He just didn't know what an artist he was when he started, but he has given us some of the most beautiful moonscapes known to human beings. And then Nicole Stott, today, who is considered an artist astronaut, one of the modern day former shuttle and space station astronauts. So thanks very much for what you and your wife do. Thanks very much for being with us this morning, and have a great Vermont day there. Take care.
Thanks a lot, Charlie.
Semper Fi, Jerry. So now, I tell you what I'm going to do. I'm going to step out of the way, and I'm going to turn it over to somebody who's going to explain how we got all these people together. So the young ones who actually did the experiments, both on Skylab and now on ISS. And in my script, it says the precocious students who did experiments on Skylab. I look at some of them and I'm not sure that they believe they were precocious. They were just really interested in curious students. So first, Melanie Gilbert, I'm going to ask her to talk a little bit about how she went about this project. She just graduated from high school. She'll enter Skidmore later this month. And she did the heavy lifting. She was the one that went out and tracked down and interviewed the Skylab alumni. So Melanie, tell us how you did all this stuff.
Thank you. I'm so glad to be here today. For the past year and a half, I've been talking with former Skylab researchers to learn how it has impacted their journeys into the career today. Finding these Skylab participants around 45 years later took some deep digging. I needed to go through high school and college alumni databases. I reached out through Facebook. I used public record search engines and even cold called scores where the names were a match in the phone book. Ultimately, I reached out to around 18 and spoke with around 8 alumni. Using a semi-structured interview guide, I had in-depth conversations with them all. We've learned that Skylab had a powerful impact on all participants' lives. It elevated their collaboration, boosted their confidence, prepared alumni for future workplaces, heightened interest and understanding of science. Working with ISS scientists and high school students across the U.S. heightened their value of teamwork. Participants were thrown into the deep end, working with high-level officials, which is exciting for high schoolers. They learned to collaborate with these scientists to conduct their experiments. As a part of the Skylab experience, they needed to share their proposals with large groups and answer lots of questions. They had to continually explain why their proposal should fly. The culmination of these events provided a powerful foundation of confidence, which helped them envision what is possible for their future careers. All of these experiences, including their early exposure to workplace, taught participants what is expected for their future, preparing them for future workplaces. By learning to conceptualize complicated scientific ideas, participants discovered that understanding other concepts came easier. This in turn increased their interest in science. The Skylab experience encouraged them to explore a wide range of careers, many in STEM. There are professors, doctors, engineers, project managers, and even a monk. But mostly, many found themselves drawn to education due to the impact of Skylab on their early educational lives. Overall, they found themselves more prepared, confident, collaborative, and obtained a deeper understanding of science. These skills significantly propelled the Skylab students' careers forward.
Fantastic. Thanks very much, Melanie, for explaining that to us. Now, the moment you've all been waiting for. Let's meet some of the students of the Skylab and International Space Station experiments. And what I'm going to do is I'm just going to alternate back and forth. So we'll go Skylab, ISS, Skylab, ISS. You get it. So each is going to give us about a 2-minute introduction to their space experiments. And then when they're all finished, in the time that we have left, I will attempt to ask some probing questions that'll give you a little bit more information. And I'm not sure that we can get this risky, but maybe I'll get some of you to help me ask questions. So we'll see how that goes. First, Dr. Kathy Jackson. Yep, that's her with Walter Cronkite in 1974. As a high school student, she designed and conducted an experiment on astronaut motor sensory adaptation. And that's exactly the one that you heard Skylab astronaut Jerry Carr talking about earlier, that he referred to as the monkey box. Maybe she'll make a comment about that. She is now a faculty researcher in teaching and learning with technology on affiliate faculty at the Pennsylvania State University. So, Kathy.
Thank you. It's really a thrill to be up here today. My motor sensory experiment was really motivated by my interest in the effect of long-duration spaceflight on human performance. I really didn't think of it as a monkey box, but how exciting it was to hear that they thought it was fun and they remembered it. And I do believe fun is an integral part of learning and education. Anyway, being on this children's TV special, What's Skylab All About, which you see me there, it was hosted by fellow Texan Walter Cronkite. Was a tremendous opportunity, and I was able to describe my experiment to an audience of young learners. And it was during the third mission, as you heard, that the astronauts performed the experiment. It was really to see if there was any change in their performance. So they did the maze early, mid, and late. And this was one of the very first experiments to really look at something like fine motor skills. And was I supposed to tell you to advance the slide?
You got it.
Well,
You got it. Yeah.
I think, well, there was a picture with Ed Gibson, astronaut Ed Gibson, actually holding the maze in space, but we'll just jump ahead real quick. So my Skylab participation was really a launch pad for many directions in my life. I was inspired by the experience with Walter Cronkite. What a powerful communicator and a big believer in space. And by my experiences conducting research and guided by NASA engineers and astronauts, these were powerful life lessons. My academic background combined with my interest in science and technology has really led to my focus on many STEM or STEAM type endeavors. Much of my career I've taught at the university level, directed a faculty center for engineers at UT Austin, mentored faculty to enhance their teaching. I conducted engineering and other educational research. And just as a final thought here, as a Skylab student, I really first experienced research and the importance of asking hard-to-answer questions. And it's that intellectual curiosity and persistence that has been a lifelong gift, and I've felt really privileged to be a part of this. Thank you.
It's one of the things that I think most of you will find who have been involved in the program or get involved in the program is that you become a member of a family. And I'm not just kidding about that. Kathy and I are sort of family because her father, John Jackson, was a mentor of mine. And when I first got to the Johnson Space Center in 1980, John was right on top of everything and made me feel very comfortable. He knew everybody in the world, to be quite honest. So if you needed a contact, you went to John Jackson. And so thank you very much. Tell your dad I said hello. He's dear to many of us. So now, let's go to an ISS experimenter. Abby Schmid. Abby is part of a high school team. She won the International Space Station National Lab Design Challenge for their bacterial lag phase experiment. That's a mouthful. Launched in 2015. She's currently a student at the University of Chicago, majoring in computational and applied mathematics. And I am actually fascinated by how she got started on this, so maybe she'll tell you. So Abby?
Thank you. So when I was a sophomore at Centaurus High School in Lafayette, Colorado, two of my friends, Brian Jack and I, wrote this grant and won it, and it was for the CASIS National Design Challenge. We then went on to lead a team with the help of our teacher, Brian Thomas, of about 20 students to build this experiment in order to study the impact of microgravity on the length of bacterial lag phase. This is our team up on the screen. So I could talk an hour probably about all the ways that this experience has impacted me and all the things that I have learned, but I'll just focus on two for today. So for one, Perseverance. Our experiment originally launched on SpaceX CRS-7 in June of 2015, which, as some of you may remember, was a failed mission and exploded about 2 minutes into launch. And so while rebuilding the experiment, we had a chance to improve our designs and protocols and perfect every step until we relaunched on Cygnus CRS-7 in 2017, which was 3 years after we first wrote that grant. The drive to push through the destruction of everything that we had built and then striving to continually improve our experiment is a mentality that I've applied to my own research at the University of Chicago. I've been working in a microbial ecology lab doing computational research for almost 2 years now, and last summer I had finished my analyses and was getting ready to write up my results for publication when I noticed a small error in one of the very first steps of my workflow. I probably could have just pushed through and published that work with the error in it. However, it didn't feel right, so I had restarted everything and took the time to improve or optimize almost every step in the process. I'm now getting back to writing that paper. And then briefly, one other impact has been on my confidence. To have a committee of scientists and engineers validate my ideas in high school gave me the confidence to constantly look for new opportunities, to be curious and take risks. Someone acknowledged my worth as a scientist, engineer, and mathematician before I did, and I cannot overstate the importance of that support in my decision to pursue math and science in college, but more importantly, in the way I see myself and what I can achieve. So I guess the only thing that's left is what I plan to do next. I'm going into my last year of college after all, and to be honest, I have no idea. So if anyone has a job opportunity, please let me know. No, I'm just kidding. In all seriousness, though, I've been trying out different options to see what sticks. As I said, I've done research at UChicago, and this summer I'm doing a data science internship with the Chicago Transit Authority. I've also been exploring fields like technical art history and dynamical systems through coursework at UChicago. So regardless of what comes next, I'm very excited, and I know that my experiences of working on this project and being engaged with the National Lab are going to continue to propel me forward.
Thanks very much, Abby. And now, Dr. Rob Staley has certainly followed a path that's near and dear to my heart, working with NASA to explore the universe as a senior manager of advanced instrument concepts at NASA's Jet Propulsion Laboratory, heading a division of 500 people. Rob, take it away.
Okay, let's go to the next slide there. What an incredible boost to a career to have occur when I was a high school junior. I had no idea what an advantage that might confer, but I've done a few things since then, which I'm going to summarize in the next couple of minutes. But you see there on the upper right of your screen is the actual hardware that was flown aboard Skylab. It was actually launched with the orbital workshop and then operated by the first crew, but because the orbital workshop had heated up, the bacteria that I was flying died. And so I was fortunate enough through the efforts of two of the people sitting in that table. I'm the one with the hair, of course, in the center. But Henry Floyd, was sort of he was the instigator of the Skylab student project along with Jack Waite, and so Dan Barstow's now in the position that Henry's sitting in there. And then Steve Hall from Marshall Space Flight Center was one of the experiment advisors spread among many of us, and they made things happen that never could have happened without them. Go to the next, please. So perhaps the most prominent highlight of my career started with the United States Postal Service coming to the Jet Propulsion Laboratory, where I work, to unveil a series of 10 postage stamps commemorating exploration of the solar system by U.S. spacecraft. They decided they needed an even number, so they put the moon in to make it 10, even though there were 9 planets back then. The textbooks have all been changed. But anyway, the artist got to the last one and said, well, what should I do? And the Postal Service employee said, so what do you mean what you do? You artist concept of the planet and the spacecraft that went by it. And well, there's only 2 problems with that. We haven't sent a spacecraft there, and so we have no idea what it looks like. So they came and unveiled these stamps at JPL, and I showed up late for the ceremony, and I looked at that last stamp, and I said, I think they're challenging us. They're saying, why not yet explored? You guys at JPL, you do planetary exploration, let's get with it. So Stacy Weinstein and I, just an hour after that ceremony, decided to start the Pluto mission. It took a very circuitous route to the launch pad, if you go to the next slide. And you'll see me there with Clyde Tombaugh and his wife Patsy in 1993. One of the first things Stacy and I did was we called up the discoverer of Pluto, Clyde Tombaugh, who discovered it in 1930, and said, you know, since you're still alive, we figured we ought to ask your permission to go to your planet. To our great relief, well, first it took us about 5 minutes to convince him it wasn't a crank call. But then when he realized we were serious, he said, absolutely, you have my permission to go. And the mission was actually then picked up by Johns Hopkins University's Applied Physics Lab and launched, as you see there, in 2006. Next slide. So I've been involved in a number of other things. One of the activities that's ongoing with a Space Act Agreement partner with NASA and JPL is to try and put up a constellation of sensors to detect wildland fires anywhere in the world within 15 minutes of when they get to a size a little smaller than this stage here. And there's a lot of interest in the firefighting community for having that early warning. So this is another way that I and teams that I've worked with have applied some of the lessons of Skylab. Next, please. And another thing I've been involved with is making spacecraft smaller, like a lot smaller. So Jordy Puig-Suari and Bob Twiggs invented CubeSats for low Earth orbit. And I went to Jordy a few years later and said, Jordy, I think I've figured out with some folks I'm working with that we can go interplanetary with them. And we proposed that concept into NASA's Innovative Advanced Concepts competition in 2011. And then just last year, the Marco A and B flew by Mars as the first instantiation of interplanetary CubeSats. That was a heck of a lot of fun, and it's brought in a much broader community that now has access to solar system exploration than before. And let's go to the next one. So you can see the results of my experiment in that angled inset. The two pictures on the top are bacteria that grew aboard Skylab on the mission that we just heard about. And the two bottom ones were ground controls that I grew. We measured differences between those. And we had to overcome a huge number of obstacles, but we got it flown. In fact, we got it flown twice. The experiment was a success. A lot of other things that I've worked with, some of them have turned out to be successes, not all of them. And you just keep pressing forward. So that's the lesson that I got from Skylab.
Thanks very much. Our next student is Deidre Morales, a high school senior at Odessa Collegiate Academy in Texas. She worked the Student Spaceflight Experiment Program to investigate bacteria biodegrading waste plastic. That means she was looking for a bacteria that would eat waste plastic. She told me mainly in the ocean. So let's hope we all learn a lot from her results. So Deidre, take it away.
Thank you, Charles. So I'm really happy to be before you here today. From a young age, I've always had an interest in science, especially space science. So as you can imagine, I was absolutely elated when the Student Spaceflight Experiments Program gave me the opportunity to design an experiment to go up to the International Space Station. So when looking for an experiment to do, I wanted to begin by identifying a problem. And a big problem that we have here on Earth is plastic pollution, especially in the oceans. So I was searching through the internet and I actually found out about this bacteria, Ideonella sacensis, and it has the ability to degrade plastic and it leaves behind no harmful residue. So it got sent up to space last year, and here I think you can see on the first section I have the bacteria itself, and I actually put a growth medium with it there. And then in the second volume, I have the plastic film that it was going to degrade in space. And the last one, the glutaraldehyde, which is a fixative, and it would stop it from growing. Last year, I also, as well as this year, I got the opportunity to present the results of my experiment at the National Space Science Museum. And it was really an honor. Actually, the day after I presented, I got to see my experiment go into space. So that was an amazing experience. Doing this and working with scientists has really opened a lot of doors for me. I've always known that that I wanted to do something with STEM, but this really helped reaffirm my decision. And in the future, I hope to go to UT Austin and study aerospace engineering.
Fantastic. Terry Quist, as a high school student in 1972, designed and conducted a Skylab experiment on neutron fluxes. He's now division chief at the National Guard Bureau Joint Intelligence Directorate. He can't tell us all the details of his current work because he'd have to shoot us. However, suffice it to say we owe him a debt of gratitude for helping keep us all safe. Terry.
Thank you. I did a little bit of everything in high school. I considered myself a generalist instead of a specialist. I was editor of this high school literary magazine. I did speech contest, I did drama, and I did science. And I did science fair projects in junior high school and senior high school, and I was very interested in atomic science and in nuclear engineering. And with all my interest, at that time I thought I was going to go into engineering and science. I was particularly fascinated by neutrons as particles. You could have called me a neutron nerd. I was really fascinated by neutrons, and when the Skylab advertisement came out, I wondered, do they know how many neutrons are shooting around in orbit? And I began reading around and found out there were all sorts of theoretical calculations. But the reason they didn't really have a good idea, an experimentally verified idea of how many neutrons there were in orbit, was because most neutron detectors at that time were very heavy and very bulky, and there was no way to send them up. So I had read an article in Scientific American about how there was a compact way to count neutrons by putting a fissionable foil next to a piece of plastic or mica. And then you can see here the copy of a picture of the detector that was designed in collaboration with me in the end for flight. When neutron flux goes through the foils, it produces fission fragments. The fission fragments go flying out through the plastic or mica, and then you etch out the tracks and count them, and you can figure out how much neutron flux there is in space. And moreover, Skylab had these large water tanks, which moderated the neutrons, which made them easier to count. And NASA was very pleased, the science community was very pleased with the results, because they saw there was about 2 times as much neutron flux as they were expecting in orbit, and it generated follow-on experiments on Apollo-Soyuz, and I believe some other flights after that. I ended up going more in the liberal arts, political science direction in college, did graduate work at Harvard in political theory and in Russian studies. Came from a military family and joined the National Guard because I figured I should be available to my country for military service if they needed me. Around 2001, I went to Bosnia for peacekeeping, and about the same time, the planes hit the towers. We had 9/11, and I spent about 13 years on rolling active duty orders because there was a high demand for my skill set. What I would say, and then you see me in uniform. I retired from uniform 4 years ago, actually, and made a horizontal move to government civilian. So I took off the uniform and put on a suit. And so now I'm doing the same thing in a suit that I was doing in a uniform. Last thing I will say is that this was incredibly valuable for me. It contributed very much to my ability to think critically about engineering and science aspects of my work in intelligence. My military career may not seem a straight follow-on, but in a way it was a continuity of my generalist approach to things in high school, because I feel as an intelligence officer in the military, I use my research, teaching, public speaking, writing, science and engineering, languages, social science. It all comes together for me, and that's why I found a home eventually with the job I have today.
Great. Thanks very much. Okay, we've got just a couple more to go, and we're going to stick with station for the last 2. So all space projects are team efforts. That's especially true with Lucilla. Did I get that right?
It's Lucelli.
Lucelli. Chucks.
It's okay.
All right. Lucelli Gonzalez and Hannah Suter from Chula Vista, California. And they're going to talk a little bit about their experiment. So whoever's going first, go.
Okay. Hi, my name is Lucelli Gonzalez.
And I'm Hannah Suter.
We go to High Tech High Chula Vista,
which is a public charter school located in San Diego, California. This past school year, our 2 classes were given the amazing opportunity to work with Quest for Space and the International Space Station.
We ran multiple experiments on heat transfer, and each person had a significant scientific role to do.
Throughout this project, we learned many important skills that will help us pursue our dreams of working in STEM. It opened my eyes to the fact that space exploration isn't just science fiction, and what isn't reality now can become it in the near future.
Working with the ISS has allowed me to discover that the sky is no longer the limit. I can reach the universe. Prior to working on this project, I had little interest in the engineering field, and I'm so grateful to have this opportunity to explore my newfound passion in space and engineering, and I want to combine it with my love of the medical field. Working on this project broadened my horizons to reach past the stars, and I look forward to seeing you in the lab.
Currently, I am in MESA, which is Math, Engineering, Science Achievement Team, which I was never expecting, but found interest for through this project. In the future, I would like to be an entrepreneur focused on computer engineering, and hopefully will become a successful woman in STEM.
My focus is to truly make the world a better place, not by sustaining life, but living in an environment where we can thrive. I want to further explore the potential of life on Mars while simultaneously finding ways to reverse the effects of global warming, ensuring safety and well-being of humanity.
Fantastic. Thanks very much. Finally, Julian Rubenfein, who carried on a multi-year legacy of the Genes in Space Student Experiment Program. At the end of this session, Boeing will announce the newest winner. So, Julian.
Thank you, Charlie. I'm the last one, so I'll keep it really short. But
You're good. You're good.
Well, if you go back one slide, I'll just say, as you said, I won the second annual Genes in Space competition when I was a sophomore in high school, and that was 3 years ago. And it really opened my eyes to how unique space science is and how fulfilling it is to be part of it. And so since then, I've stuck around. And this is a picture of me interning at Johnson Space Center this summer, where I've been helping to develop DNA sequencing capabilities for the ISS. So on the left, I'm taking a microbial sample, and on the right, astronaut Christina Cook is up there, and she's still up there sequencing that DNA. So if you go to the next one now. So for those of you who don't know, Genes in Space is a national competition that runs every year. It's sponsored by Boeing, Mini-PCR, New England Biolabs, and others. And the idea is that high school students from around the nation will propose molecular biology experiments to be run on the ISS. And the main requirement is that those experiments leverage what's called PCR, which is a cornerstone biochemical technique that scientists use to study DNA. And that only became available to use on the ISS in 2016 with the invention of a miniaturized machine called the Mini-PCR, which really opened the door for all kinds of molecular biology experiments to be performed on orbit completely independently without samples having to be flown back and forth from Earth. And so when I proposed my experiments, I wanted to develop a way for scientists to study telomeres, which are the protective caps on the tips of human chromosomes made of DNA and protein, for people to be able to study those in space without having to fly samples back and forth from Earth. And so when astronauts Peggy Whitson and Jack Fisher performed our experiments up there, we showed that it's possible to work with telomeric DNA in microgravity, and we were the first to show the use of a specific assay to do that as well. And of course, our work directly preceded the twin study, a big focus of which was telomere science, so that was tremendously exciting for me to see so much interest in that little niche of biology that I'd found my way into. And I think my last slide got cut, so I'll just say, I'm heading into college now. I'll be studying biophysics, and this experience has definitely changed my life, shaped my interests, will continue to do so, something I'm tremendously grateful for.
Fantastic. Well, we tried to give you just a snapshot of some of the experiments that were flown on Skylab and station. I thought there were some remarkable stories. We got about 10 minutes left, so I will try to be succinct in my questions. So I picked some that I want to ask you all specifically. I'm going to start with you, Terry, since we talked a little bit about this. You mentioned the fact that you had, you flew an experiment that had radiation or radioactive material on board. How difficult was it to get that past NASA?
It almost killed my experiment. And the attitude at first with the NASA folks, generally, I'm saying generally, was, well, this is really interesting. Too bad we can't fly it because it's got radioactive materials. But there were, you were introduced to Mr. Floyd and Mr. Waite as being advocates for us, and they pushed real hard, and they found out, no, wait, we used the same technology on Apollo 17 to do some soil investigations. So if they went through all of the safety protocols to put this on Apollo 17, I'm sure we can do it on Skylab, and that reawakened interest in following through with my experiment. And I just want to emphasize, when you find those advocates, when you do something like that, grab hold of them and they will help you through the ways of the bureaucracy you don't understand when you're beginning your career.
Fantastic. Rob, let me go to you next. Can you compare your anticipated career path 45 years ago, or however many years ago it was, to the actual path that you took?
It's funny,
in your asking that question, you're assuming I had an anticipated career path. That's true. You know, what is it? Joseph Campbell said, follow your bliss. Well, follow your bliss and get a paycheck, that combination works better than just one or the other. And so I didn't really have a career path. I fully expected to go on and get a master's in college, and in the middle of my senior year, I got terminal senioritis and decided to go to work for JPL working on the Voyager project. And I've basically just followed my nose since then. I've had a number of different jobs at JPL. I've had some offers outside, not taken any of them. I worked with a nonprofit for a number of years, which really helped my career by getting out there with other people. But yeah, followed my nose. That's been my career path.
Great. Abby, let me ask you, you know, after working on ISS, what other interests do you have, and how do you think you can connect them to space?
When I got to college, I discovered that I'm actually really interested in art history, and so I've also added on an art history minor in Mesoamerican art. And one of the big problems with archaeology and you know, ancient art and looking for sites where these pieces still exist is looting. And so I know that there's a project that takes advantage of our remote sensing technology in order to look for signs of looting from space in order to send professionals into that location to try to find out what's going on. And so projects like that are very interesting to me, and I'm going to start looking into that a little bit as well.
Kathy, you had what some might consider to be a relatively simple looking experiment, but how did you find the lab in space to be different from your lab on the ground?
Well, space is limited. Weight mattered quite a bit. Even getting it to be functional was a bit of a task. The engineers and the support at NASA certainly helped to figure that out. So that was different. And one thing I too wanted to point out, when we're doing things like, we don't want to necessarily feel like we're being judged. And so there was some concern, you know, that with the astronauts, it wasn't necessarily to see who was the fastest, it was to check performance. And so when their data came back, it was anonymous, even though there were 3 of them. So, you know, we didn't want them comparing each other. And I found that interesting, too. As a high schooler, I hadn't thought of that. So.
Great. Deidre, you talked a little bit about this, but let me poke and probe a little bit deeper. You know, how did this experience affect? I'm an emotional person, so I'm going to ask you about your emotions. How did this experiment or this opportunity affect your emotions, your confidence, your joy of science, and your career dreams?
I think it definitely heightened my interest in science, and it made me more optimistic about where I could be in a few years and where I could take my career. So I'm really grateful for this. It's opened so many doors for me, including being able to speak here and at the Air and Space Museum in DC. So yeah.
Fantastic. Lucely and Hannah, and you can give me individual answers. This is not a group answer, all right? How can we open up these experiences to many more students? How do we find a way to give more students an opportunity to see what you two have seen?
I think overall we should just create more awareness of STEM, because before this project I had no idea what I was doing. Like, I had no interest in coding as well either. And through this project I learned a lot about coding, and seeing my work actually go to space and seeing it do something made me feel like it was important. So for other students to know that their work is important as well, I feel like that would add more awareness to it.
Well, I feel that we should promote STEM to all schools because this opened many doors for me. Like I said, I wasn't interested in the engineering field, and once I was able to be the mechanical engineer for the project, I just fell in love. Like, I couldn't stop building. I kept talking to my physics teacher about it, and my mom also, and it just shows it proves how little things like that can open so many opportunities, and it's easier for you to find what you will love to do in the future and not feel like you have to work for it.
Great. Julian, I'm going to ask you the next to the last question. You know, as the NASA administrator, I was always criticized because we weren't getting people interested in science, and we weren't getting people interested in exploration, and whatever happened to the good old days. Advice to a former NASA administrator. How can we rejuvenate the passion for space exploration in students today, you know, so that it becomes as active and as passionate as people think it was in the days of Skylab and Apollo?
Well, that's a difficult question. I mean, space is space, you know, I mean, like that much has not changed. I think it is an awareness issue for sure. I mean, you know, you still see people walking around with NASA t-shirts everywhere, you know, there's still, there's interest. But of course, there's a lot of people who don't know that there is a space station right now. They don't know that there are astronauts up there, and far less know that there are opportunities for students to actually send experiments up there. And so I would definitely say, you know, making that, you know, known to people, known to students would definitely help.
Great.
You.
And the final question, Melania, say it for me, Malena. I am just dying to find out, what'd you learn about the monk?
About the monk? Oh, well, he took great pride in his Skylab days, but after going through college and grad school, graduating with lots of degrees in STEM, he decided to renounce that part of his life and go more for the theological route. But he still accredits Skylab for a lot of his curiosity about the world today.
Fantastic. And as we bid you all adieu and move on with the rest of the program, let me kind of go back to something that Julian talked about, and it's about instilling passion. How many of you consider yourselves storytellers? Everybody in this audience ought to get into the world of storytelling. We will instill passion in people when we learn to tell our story. It makes no difference what you do. It makes no difference where you come from. What's most important is for you to share your experience and your passion with somebody else. Your classmates, talk to them about what you're doing. You know, tell them about your experiences with Station and Skylab, because they don't know. Your family members, they don't know. Your church, your teams and everything. Become storytellers, become much better storytellers, and I think we won't have any problem in reinstilling the passion that a lot of people think we used to have. This has been a pleasure for me. Let me thank Dan and the rest of the team for allowing me to do it. Thanks very much to the panelists here, and have a great day. Thank you.
And you can all exit the stage now. Well, thank you so much. What inspiring these students are, and just wonderful. And Charlie, thank you for coming from your heart to share the questions and comments. Well, as I mentioned, there are two parts of this program. We've just completed the first part, which is these panelists and these students. But I'd like to think for a moment about the challenge that Charlie said about how do we take all this wonderful work and reach many more. The Space Station Explorers program and all of our partners, we've reached over 2 million people last year. We're on our way to more than that. But it's not what we do, it's what you all do. So what we're working on is how to create packages and tools that help spread this. And that's done through partnerships, some major partnerships, and there are two of them that we'd like to announce today. The first, I'd like to invite Steve Rothstein to join us. Instead of viewing each of these projects as individual ones, how do we collectively work together, have them be an integrated package? That's the question that Steve Rothstein and I were talking about. He's the executive director of the John F. Kennedy Library Foundation, and would like to tell you about the project that we're launching here. Yeah, you'll take it. Yeah.
So President Kennedy obviously believed in big, bold ideas, and as part of the John F. Kennedy Library Foundation, we want to continue that. So we had a variety of things. We had distinguished speakers like General Bolden, Michael Collins, Jeff Bezos. We have an augmented reality version of Apollo 11 and lots of other things. But the real reason we're here today is this exciting program with the JFK Space Labs. I'll bet all of you went to schools that had a chem lab or a bio lab or a physics lab. But I'll bet, maybe with a few exceptions in this room, that not many of you went to a school with a space lab. So we're announcing the first 100 JFK Space Labs across the country at schools and boys and girls clubs in conjunction with Raytheon and obviously Dan and the amazing team there and the boys and girls clubs. We're taking experiments that have either been done or have been done at the space station and bring them to schools. So to answer one of the questions that General Bolden says, how to let more people know, we'd like to have more JFK Space Labs across the country. I'd love to talk to you about it. Thank you so much, and special thanks to Dan and his team.
The second major partnership, and each of these honors the heritage of either John F. Kennedy or in this case Sally Ride, who passed away recently, and it's a little while ago. It's sad to lose Sally. We were going to have her partner, Tam O'Shaughnessy, join us. Unfortunately, she's ill, is unable to make it. Instead, we have Shirley Cohen, who works with the Sally Ride Science Program to talk about how to encourage girls in science.
Hi, everyone. Tam would love to be here, but unfortunately she could not be, so I'll be speaking on her behalf. My name is Shirley Cohen, and I'm an instructor with Sally Ride Science, specifically the lead instructor for our Quest Space Kit classes. I've been a part of the team initiating this program, and I'm so thrilled about its success thus far. So here's a message to you all from Tam. Sally Ride Science at UC San Diego is proud to partner with Space Tango and Quest for Space to offer workshops across the country. This is a terrific opportunity for students to learn thermodynamics, program heat transfer experiments, and then have them uploaded to the International Space Station and run in low gravity. This partnership carries on Sally Ride's legacy of involving girls and boys from all backgrounds in space. 25 years ago, Sally started EarthCam, which was renamed Sally Ride EarthCam in her honor. Sally's idea was for students to learn about Earth from the unique perspective of space. Students learn about Earth's rotation and orbit around the sun, day and night, ISS orbits, latitude and longitude, and geography, and then they use this knowledge to select places on Earth to photograph from space. Students' image coordinates are uploaded to the ISS, an onboard digital camera snaps the photos, and students receive copies of their images. Go to the next slide. Oh, you're already on the next slide.
Oh, nope, that's it.
Similarly, the partnership between Space Tango, Quest for Space, and Sally Ride Science at UC San Diego gives students an amazing learning experience, hands-on thermodynamics and coding, and the wonders of space. Sally would be thrilled. I'm also very excited to announce the national rollout of our program. We're looking to launch at locations all across the country, targeting the hotbeds of tech, including Houston, Boston, and right here in Atlanta. With that, I hope you all enjoy the rest of STEM Day. Thank you.
Thank you. Very good. Now I'd like to turn this over to Kevin Foley from Boeing. Is Kevin here? Oh, okay. The Boeing every year announces the Genes in Space winners. So turn it over to you now.
Okay, hello everybody. Hello again, I'm Mark Mulqueen, ISS Program Manager with the Boeing Company. Julian, give a great shout out to Genes in Space. I talked about it Tuesday a little bit. Again, this is a STEM program for students from 7th grade through 12th to do a DNA experiment that would be selected and that benefits the health and understanding of humans in zero gravity. So This is our 5th year. This year we had over 800 proposals received across the United States. We had a team that down selected those proposals to 5 teams that we have invited here to Atlanta. Think about it. When you were about 15 years old, did you want to go to a conference and sit and listen to different people talk about space, or you would like to go outside and do something interesting in your neighborhood or with your friends? So, congratulations to all of you and for making wise decisions, and thank you to your parents, because I know they help you in everything you do, and they're good examples to you, and you made wise decisions to spend this summer doing something different. And hearing from Julian a little bit earlier, your careers could really leap off into both what you study in college, what you choose to be as a scientist, engineer, and certainly a space leader. So I'm going to read the proposals, the 5 of them. I'll read the high school that the team members came from, and then the team members' names. What I'd like to do when I read the team members' names, have you stand up. You can wave to the crowd. We're going to have we'll clap for everyone at the end, so don't think you're going to miss an opportunity. Okay, the first proposal was mitochondrial DNA repair dynamics in microgravity from a team in Smithtown High School East in St. James, New York. Kevin Chen and Alexa Nee, please stand. Proposal 2, cellular mechanisms underlying astronaut bone density loss. Claire Jen, Tori Sodendi, and Jessica Zhang. Proposal 3, neurophysiology and plasticity in mammals during long-term space flight. From Troy High School, Troy, Michigan, Fansum Sampson and Yuji Wang. Proposal 4, influence of microgravity on cytoskeleton organisms during gamete formation. An individual from the International Academy, Bloomfield Township, Michigan, Vivian Yee. And proposal 5, reassortment of genetic material in the influenza A virus in space. From Clear Lake High School in Houston, Texas, Abinad Parthas Arathi. Okay, so it is with my honor and privilege to announce this year's winner of Genes in Space competition. All right. With the team from Troy, Michigan, studying the neurological implications of long-duration spaceflight, Finsum Sampson and Yuji Wang, please join me on stage.
Congratulations. Thank you so much. And finally, we announce the winners of the Student and Educator of the Year Award. The first one is Ashley Smith for the Educator of the Year Award. Ashley? We tried hard to find a picture of Ashley that was just Ashley, and you can't do it. She's always with her kids, and that's your lifeblood. Ashley has been teaching physical science for 16 years at Cranbrook School in Bloomfield Hills, Michigan. She was the 2017 recipient of the Alan Shepard Technology and Education Award presented by NASA, the Astronaut Memorial Foundation, and the Space Foundation. She's been an active teacher ambassador, our educational ambassador program with hundreds of educators, and has been a real key person in that organization. She developed the Space Station Explorer's Welcome to the ISS STEM Kit for educators, now used in schools worldwide. So congratulations. Yeah. Well, the student of the year, actually, you already know. So, Abby Schmidt, will you please come back on stage? This award recognizes a student who participated in a Space Station Explorers program with remarkable motivation and passion, and even more importantly, took steps further using the momentum of that experience to propel them forward to new achievements and help other students do the same. You've already heard her describe her experiment and her ambitious studies at the University of Chicago. We've gotten to know Abby over these years as an outstanding student, scientist, colleague, and mentor. Abby has also been featured in the Emmy Award-winning PBS children's series, Sci Girls, as a role model inspiring young girls to pursue STEM careers. Congratulations, Abby. And the last ones to honor are a group of 10 middle and high school students who submitted posters and technical presentations. They were reviewed by a number of you, and thank you for doing that reviewing. They each received an honorarium to help bring them to this event. So there are 10 of them who have received this award for their, this recognition, honorarium, for the stellar poster and presentation. I think they're at one of the tables around here. Could they stand, please? There we go. Well, this has really been a remarkable session, from students who worked 45 years ago to students who are working now to students who are working in the future. Most importantly, I want to thank all of you who carry on this vision. Each of you, as scientists, engineers, business people, students, educators, carry on the grand cause of trying to engage kids in STEM. So a big round of applause for all of you, Space Station Explorers. Back to you, Jim.